Good morning, my dear students. Today, I am going to take class regarding tricks to solve NEET questions under this classification of elements and periodic properties. This is the third unit in +1. So under this unit, so far, for the last 6 years in NEET common entrance examination of conducted by Government of India, what are the questions asked? I am going to discuss. I am Dr.R.G, Professor of Chemistry, who is taking class for you. So, before attending this unit, the student point of view, I want to give important information. What are the topics we have to study? So mainly there are two types. One is the two subtopics you have to study. One is types of periodic tables. Another is periodic properties. Kindly follow. So far, nearly 120 elements were known so far, and specifically name was also given according to IUPAC. And only these elements may be classified physically as well as chemically. Everything we have discussed under the basic concept of chemistry. Under this matter and its classification we have discussed. Physically 5 types, chemically there are different types, finally atom and molecules. Kindly follow. So these period, when the elements were discovered, the scientists, they want to arrange the elements in a group. So to study the physical and chemical properties. So different person tried and different persons succeeded, and you have different periodic tables. And another is periodic properties. Let me give in detail, kindly follow. So what you have to study? Under the periodic properties, you have to study what is Brout hypothesis. Number 2, law of triads, introduced by John Dobereiner in 1829. 3. Law of octaves, introduced by John Newland, 1865. Number 4. Lothar-Meyer's arrangement, 1869. And number 5. Mendeleev's periodic table, introduced in 1869. Modern periodic table, introduced by Moseley in 1913. Please follow. Modern periodic table based on atomic number. The previous one, everything based on atomic mass. Kindly follow the difference. Moseley introduced the atomic number. And finally, long form of periodic table, different people are given starting from Bohr. Okay, so these are the merits and demerits of this periodic table you have to study. Coming for the periodic properties. What is the periodic property? Any property which varies across the group or across the period. When you move, it is a periodic property. Either increases or decreases. Kindly follow. Among this, I want to give you important information. Please follow, my dear student. This information will not be given in any book. It is based on experience. Atomic size is the most important periodic property. I am going to discuss everything. So, atomic size, please memorize, increases across the group. This is from top to bottom. But you know, before that, let me give you the periodic table. In the periodic table, there are 18 groups, 7 periods. Please follow. Long form of periodic table, 18 groups, 7 periods. So, along the group, the atomic size increases. Along the period, it is decreases. Please memorize this. Reason I can easily explain, because when you move down, let me take a first group, alkali metals, hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. Just imagine, according to Bohr, first orbital is, this is 1 shell, center is nucleus. So hydrogen is 1s, lithium 1s, 2s. Kindly follow. The size increases. Then 3. Then is going on 4, 5, 6. That means distance. Then actually, what is atomic size? The distance between the central nucleus and the outermost electron is called atomic size. So, when you move down across the group, atomic size increases. You know the reason now very clearly. When you move across the period, decreases. You should be very careful. Because even though atomic number increases, still let me take the second period. Kindly follow. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. This is the period going. Period along the period. So what will happen now? When we are adding, the atomic number increases, proportionately proton increases, electron increases. We know now atomic number equal to total number of proton equal to total number of electrons. So what is happening here? The electrons added in the same shell. Please follow. When you move across the period, electron added in the same shell, proportionately proton also increases. So proton attracts the electronic cloud. So electronic cloud shrinks, size decreases. This is the reason when we move across the period, atomic size always increases. Now I want to give the clue here, students. This you should keep it in your mind, memorize it. Atomic size increases across the group, decreases across the period. All other periodic properties kindly follow. Ionization energy, electron affinity, electronegativity, these three important, just reverse of atomic size. Reverse. That means across the group decreases, across the period increases. This you keep it in mind. This is the information I want to give as a tricks to solve problem easily. Let me take the question number 1 first. This question was asked in NEET 17. Let me read the question. The element atomic number equal to 114 has been discovered recently. So we can say 114. It will belong to which of the family group and electronic configuration? This is the question. So which group it belongs? They have given option 4 group. Nitrogen family, electronic configuration is given already. Halogen family, carbon family, oxygen family. Kindly follow. Before explaining these tricks, let me introduce under what topic and what subtopic this is asked. This question, kindly follow, as usual coming under classification of elements. There is no periodic property. Under the classification based on electronic configuration. That is specifically electronic configuration subtopic. Kindly follow. Now, let me come for the answer now. Please, I am going to identify where should be 114. What you have to do immediately, the tricks here, you write these elements, the inert gas element first. Here I want to give, my dear student, please memorize what are the groups and period you have to memorize. You have to memorize first groups, alkali, first group, you have to, group 1 you have to memorize, group 2 you have to memorize, boron family 13 you have to memorize, 14, 15, 16, 17, and 18 groups element you have to memorize. So 1, 2 alkali and alkaline metals, boron family, carbon family, nitrogen family, here it is oxygen family, fluorine family, helium family, inert gas. So these group elements order you should memorize. And along the automatically, if you write this one, you know the only most important is in the fourth period, the transition, first transition elements is coming now, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. This should be memorized. Please follow. This also should be memorized. Simply I can say it is D1, D2, D3, D4, etc. is going up to D10. Only exception is in chromium D4S2 it will come. It is D5S1 we have to write. Half filled and completely filled. Theory I have discussed. The same way copper D9S1, D9S2 will come. So we have to write D10S1. 3D10, 4S1. Kindly follow. So these should be memorized. So students, please memorize first group, second group, the 13th group boron family, 14th group carbon family, 15th group nitrogen family, 16th group oxygen family, 17th group fluorine family, and the 18th group inert gas elements. And also the first transition element, the order scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, you have to memorize. Okay. So now I have to find out 114 comes under what family. What I am doing now, I am first writing this helium, neon, argon, krypton, xenon, radon. So how do I remember the atomic number? Kindly follow. Hydrogen is number 1 atomic number, helium is 2. So first period only 2 elements. The second period, third period only 8 elements. So 2 plus 8, please follow, 10. 10 plus 8, 18. So I have written. Then fourth period onwards, coming the transition elements. So here, instead of 8, 18 is coming. Kindly follow. 18 groups. So the 18 plus 18, kindly follow, 36. 36 plus 18, 54. Then after this, 1, 2, 3, 4, 5. Now 6 and 7, what will happen now? Kindly follow. Again, 32 elements are there. So 54 plus 32, 86. 86 plus 32, 118. So 118 is belonging to the inert gas configuration. Kindly follow. So what we have to find out? 114. So simply I have to write this at least second period. That is because I have asked this period. Boron family, carbon family, nitrogen, oxygen. So I am writing 118 and from that left side I am reducing 1. So fluorine family, the element will be 117. Oxygen family 116. Nitrogen family 115. So automatically carbon family only it belongs. That means the element having atomic number 114 belongs to carbon family. Very, very easy. This is the short road you have to find out. So I am giving all this explanation. But in the examination, you need not do all these things. Simply write this, find out the 118. From that, go left side, find out this. This will take only 10 seconds or 15 seconds. Please follow. So the correct answer is C. Kindly follow. C is the correct answer. That is carbon family. That is, inert gas configuration is radon plus 5F14, 6D10, 7S2, 7P2. I hope you have understand the questions. Now, question number 2. This is asked in the year 2018. NEET 2018, this question is asked. Kindly follow. Let me read the question. The correct order of atomic radii in group 30. In group 30, you know boron family. Boron family means immediately you have, I told you have to memorize boron, aluminium, gallium, indium, thallium. Immediately you have to memorize and write it. This is the family. So what they are asking, the correct order of atomic radii. So normally we informed you this is the expected order of increasing order. Increasing order. But when they are asking question mean there may be any problem will be there, exception may be there. That's why specifically they are asking. So you should be very careful. This is the expected order. What should be the correct order that we have to identify? Kindly follow. So thallium is always there. This is not there. So this is the most important. Next comes indium. So the second is these two only possibility. Third is gallium. So automatically kindly follow this, the thallium, indium and then gallium here. Kindly follow. Thallium, indium, gallium. So this is the way we are going. Okay. Now let me explain the reason, the topic under which it is asked. So this question is asked under the classification of element, actually because of the periodic classification. Under the property, periodic property, atomic radius, this question is asked. Let me explain what is atomic radius, what is van der Waals radius, what is ionic radius. Because even though that is our aim is not only to find out answer, you must know the concept based on that one. So let me explain. What is atomic size, atomic radius? Definition kindly follow. The distance between the center of the nucleus and the outermost shell of electron is called atomic size. Suppose I take hydrogen 1s1. So 1s1 center, 1 proton, outer shell, 1 electron. This distance I will call it as atomic radius. Kindly follow. There is another important information is there. There is atomic radius, another is covalent radius. They are synonymous. Whenever atomic element, we can specifically use atomic radius. Whenever the molecular element like H2, Cl2, etc., instead of specifying atomic radius, we will use covalent radius. Because one half of the distance between two nucleus, it is covalent radius. Now, so let me specify generally atomic size, that atomic radius or covalent radius. There are one more radius is called van der Waals radius. I will explain. Van der Waals radius always greater than atomic radius. And third one is ionic radius. So among the radius there are three types. Please follow. Your book may not give this information. Question may be asked. Let me explain now. By taking hydrogen as an example, I am going to explain the covalent radius. One half of the distance between the nuclei of two covalently bonded molecules is called covalent radius. Please follow. Atomic and covalent is synonymous, I told you. But covalent you can apply only for an element, molecular element. Or molecule, kindly follow. See, say for example, hydrogen. So I measured the distance between two hydrogen atoms, that is two nucleus. The distance is 0.074 Armstrong unit. And half of this, that is nothing but covalent radius, 0.37 Armstrong unit. This is covalent radius. Please follow. Atomic or covalent radius increases across the group, decreases across the period. This is the covalent radius, the diagram you can see. Now, coming for the covalent radius, it is a periodic property. Why periodic property? It increases across the group, it increases across the group, decreases across the period. Decreases across the period. Increases across a group, decreases across a period. That's why it is a periodic property. Covalent radius, kindly follow. So proof I am giving here. What is the proof now? I am plotting atomic radius versus atomic number. So I am taking the second period. Kindly follow. Second period I am taking. I am just calculating the covalent radius and plotting here. Just see lithium, beryllium, boron, carbon, nitrogen, oxygen, flame. Just see the whenever atomic number increases proportionately, just see here, atomic radius also, the correspondingly decreases. Kindly follow. Along the period, decreases. Kindly see here. This is the atomic radius coming here, coming here, coming. The fluorine is the lowest atomic radius. So along the, I am giving the proof now directly. This is given in our book. Kindly verify. Then across the group I can give. First say I will take alkali metal. First group. Among the first, let me take lithium, sodium, potassium, rubidium, cesium. Francium I am not taking because it is radioactive. So when you measure this radius, it is increasing. So proof, very clear proof. Atomic radius increases, that is covalent radius increases across the group. So actually, strictly speaking, covalent radius applicable only for hydrogen, whereas all other elements, atomic radius we have to say. So coming for halogen family, again fluorine, chlorine, bromine, iodine, it is there. So it is again atomic radius. Now when you come down across the group, it increases. It's a proof for this one, periodic property. Now next is, I told you, what is van der Waals radius? Let me define the definition, you can understand. Van der Waals radius is defined what way? 1/2 of the distance between two nuclei of non-bonded atom. Please follow. Non-bonded atoms of two adjacent molecules in a solid state. So we have to take a solid state. In solid state, we have to take adjacent two molecules. And that 1/2 of the distance between two non-bonded atoms is called van der Waals radius. So how here, just see here, this is one atom, this is another atom. Kindly follow, this is a molecule, this is a molecule. Now what I am taking? I am taking only this. This is the distance between two nuclei of non-bonded atom. Half of this distance, this is called van der Waals radius. Please follow. So this van der Waals radius always greater than covalent radius. Please follow. Please keep it in your mind. Sometime question can be asked. Now, coming for ionic radius. What is meant by ion? Ion may be a positive ion or negative ion. Let me say now. Distance between the center of the nucleus and the outermost electronic cloud in an ion is called ionic radius. Please follow. So, what will happen when it is becoming, this is question also, you can expect question here. Number of questions will be asked. See, a positive ion is always smaller than neutral atom. How? Let me explain. A positive ion always smaller than neutral atom. Say for example, you take lithium electronic configuration 1s2 2s1. 1s2 2s1. So based on Bohr atomic theory, I am showing like this. First level 2 electron is present. Second is 1 electron is present. We are not showing the proton because it will be complicated to though the right inside the nucleus. So we are interested only electronic configuration. So what will happen when you remove 1 electron? So what will happen now? The second shell vanishes. So this is the size of the lithium plus resembling helium. Please follow. So always when it is undergoing positive ion or negative ion, it will resemble the nearest electronic configuration. Please follow. That is the mode. That's why it is more stable. Kindly follow. So what will happen now? So positive ion always smaller than neutral atom. So this is the case for all the metals present in this. Hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Kindly follow. Let me come for the negative ion. Let me take chlorine. Fluorine, next comes chlorine. Chlorine means 3s2 3p5. This is the outermost electronic configuration. So 1s2, 2s2 2p6, then comes 3s2 3p5. So 3s2 3p means 7 electron is present in the outermost. Kindly follow. Count the number, 7 electron. So if you add 1 electron, that is electron affinity. So what is happening now? 8 electron becomes. When it is becoming 8 electron, now near this, what will happen now? With respect to helium, the first member, inert gas element. Next comes fluorine, the neon is the second. This is argon. So resembling argon configuration. Kindly follow. So what is happening now? Why the negative ion is always larger than neutral atom? Because when you compare the chlorine and compare this chlorine ion, kindly follow, protons are same, when electrons are different. One electron is excess in this chlorine atom, chlorine ion. So the control of protons is not there with the extra electron added. So it is moving slightly far away from the central nucleus. So size always increases. So F minus, so I minus greater than Br minus greater than Cl minus greater than F minus. So this is the information you need. So I will go for the questions now. Please follow the correct order of atomic radii in group 13 element is, that is boron family. So I have written value. Kindly follow. This is the order. So the one exception is there. That is gallium is not obeying the order. That's why this question is asked. So I am giving the values. Please follow. So what you have to remember, when you come for 13th group, exception is 13. 13 is the helium. Gallium is not obeying the order. Kindly follow. Let me give you the values. You can easily understand this. So boron 87 picometer, aluminium 143 picometer, gallium 136, then indium 220, thallium 220 approximate. Kindly follow. It should be increasing order as per the rule, expected rule. So 87 143 means it should be greater than 143. But gallium exceptionally 136. So what is happening now? It is going here. So order is now changed. So first boron, next gallium, next aluminium and indium thallium. So what is you have to memorize? Thallium is number 1. The last one it is boron. Kindly follow. Then gallium is there. So second will be gallium. So that is the idea you must know. So gallium is the exceptional case. Just see now the answer refined where it is. So thallium is number 1, indium. So kindly follow aluminium, gallium, it is exchanging the position. So this is the correct answer. So what they are expecting? You are expecting boron, aluminium, gallium, indium, thallium, the normal order. No, the order is changed. Instead of after aluminium, gallium, so it is coming before. So that's why this question is asked, exceptional case. Please follow. Let me go for the third question. For the second period of elements, the correct increasing order of ionization enthalpy or ionization energy. Very, very interesting question. So they have given 4 options. Option A, option B, option C, option D. Kindly follow. For the second period, I already told you what is second period. They are given this way. That is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. This is the formula. So what is the normal order we are expecting order regarding ionization energy? I told you atomic size increases across the group, atomic size decreases across the period. All the other periodic properties are reversed. So across the period, size decreases, so ionization increases. We are expecting you should increase across the order. So what is the expected order then? The neon greater than fluorine, greater than oxygen, greater than nitrogen, greater than carbon, greater than boron, greater than beryllium, greater than lithium. This is the expected order. But order is not like that. Real order is different because the ionization energy can be measured experimentally. So what is the real order? How to identify? So this can be explained theoretically. Kindly follow me first now. Now, before that, I can give you information. This is the question asked under the classification of element and periodicity, and specifically under periodic properties, ionization energy. So let me explain. What is ionization energy? What are the factors that affect the ionization energy? Ionization energy of an element is defined as the amount of energy required, please follow, required to remove most loosely bound electron from the outermost shell of an isolated gaseous atom of an element, resulting in the formation of unipositive ion. Please follow. This is the general form representation. This is the specific. M, gas. M is an element, gas. Why specifically M is given? Because normally positive in indication. So M1 plus 1 electron. So this is first ionization energy. If you remove one more electron, second. If you remove one more, third. Like that question that you must understand. Kindly follow. So it is the energy required to remove most loosely bound electron from the outermost shell of isolated gaseous atom of an element, resulting in the formation of positive ion. It is ionization energy. Ionization energy is a periodic property. How? It decreases across the group, reverse of size, please follow, increases across the period. Now, I am giving the proof. This is already there in your book, kindly follow. This is the ionization energy in closable form. I am plotting versus atomic number. So, which is the highest atomic, the ionization energy? Helium, kindly follow. Helium is having highest ionization energy. So, I want to record here one important information. So, in the periodic table, the element having highest ionization energy is helium. Please follow. Just like highest, the fluorine is the element having highest electronegativity. Same way, chlorine is having highest electron affinity. Please follow. Highest electron affinity. So, these three properties I am giving specifically this. Please note this one. So, the idea here it is, all the inert gas have high the ionization energy, whereas coming for hydrogen, lithium, sodium, potassium, rubidium, cesium, that is the first group, ionization energy low. So when you move across the group, ionization energy increases. This is a proof, very clear proof. So lower the ionization energy, easily electron will be removed, so it will undergo ionization. Please follow. Now, what are the factors which will affect the ionization energy? I will not go in detail. So if you want detail, go for the particular chapter. So the factors that influence ionization energy: atomic size, screening effect, nuclear charge, half-filled and completely filled orbital, nature of orbital. Kindly follow. In this question, what we are you going to use only this one. This idea. This is the factor. This factor I am going to take to explain the question. Half-filled or completely filled orbital will influence ionization energy. Kindly follow. So first question number 3. I am writing this is the order, expected order. Please follow. Neon greater than fluorine, greater than oxygen, greater than nitrogen, greater than carbon, greater than boron, beryllium, lithium. Please follow across the period. This is expected. What is the real order? I am changing the real order. Kindly follow now. So this is the expected order. This is actually original. This is the expected order. I am now real order is here. What is now? See the change now. It is boron and beryllium exchanges the place. And the same way oxygen and nitrogen exchanges the place. So this is the correct answer. So I have to give reason. So if you compare this in your original option, you will get the correct answer. How this is? This is based on half-filled and completely filled orbital. I told you the factor. So you take boron, this is the original, expected order. Beryllium is 2s2. Kindly follow. 1s2, 2s2. Then boron is 1s2, 2s2, 2p1 configuration. So if you take 2s2, 2p1 and if you take 2s2, this is completely stable when compared to boron, because p1 is incompletely, it's easily, it can be removed. So when you compare beryllium and boron, removal of electron is very, very difficult in a completely shelled to remove electron. So comparatively boron, beryllium is having higher ionization energy. I am changing the position due to completely filled orbital. The same way I am going for oxygen and nitrogen. Normal order, oxygen should be greater than nitrogen. So what is the configuration here? P3, S2, P3. That is 2s2, 2p3 is the outermost nitrogen. This is 2s2, 2p4 oxygen. Kindly follow. So when you come for nitrogen, S2P3 half filled. P3, P means 3p orbital, 6 electrons should be there. The half is P3. So half filled orbital highly stable. So removal of electron from the half filled nitrogen is very, very difficult. So comparatively with oxygen, nitrogen is greater than oxygen. That is, they are changing the position. So I am changing the position. So only two I am changing. So oxygen I am changing the position, nitrogen coming front. The same way the beryllium coming front, boron going this. This is the correct order of ionization energy. Now you compare this one, kindly follow. Lithium, the next beryllium, kindly follow. Now you compare with your original, then you can understand the order. So this is the correct answer. Kindly follow. So I changed nitrogen exchanged, beryllium exchanged. Please follow. So that's why this question is very, very important. Next, question number 4. Which is the correct thermal stability order for H2E? E, they are explaining and giving us the oxygen family. What is the oxygen family? Oxygen, sulfur, selenium, tellurium, polonium. Please follow. That's why I told you, you have to memorize all the family. So what is the given stability they are asking? So across the group, now what is happening? Stability order across the period, what is happening? So, but this is the question across the group, so we will concentrate on this. One important information here I want to give, stability when they are asking, what is the normally stable we can compare. Since it is hydrogen is involved, immediately it has to come to your mind, hydrogen bond. It has to come to your the mind, hydrogen bond. This is the tricks you have to follow. What is hydrogen bond? Kindly follow, let me define now. What is the hydrogen bond? Okay, I will come later. Definition of the discussion I am going to give now, so I need not repeat again. So I will explain here. Kindly follow. So, in this case, this question is asked under the classification of element and properties and specifically subtopic hydrogen bond based on stability. Hydrogen bond. Let me explain. What is hydrogen bond? What are the types of hydrogen bond? What are the properties of hydrogen bond? Kindly follow. When a hydrogen atom is placed between two electronegative atoms, then the force of attraction between two hydrogen atoms and the non-bond, between hydrogen atom and non-bonded more electronegative atom. Please follow. The force of attraction between hydrogen atom and non-bonded more electronegative atom. So the hydrogen which is not bonded to more electronegative atom, there is some sort of force. That force we will call it as hydrogen bond. It is called hydrogen bond. Hydrogen bond strength, it is approximately 20.8 kilojoule per mole. This you have to memorize. Sometime question can be asked. The strength of hydrogen bond is 20.8, 18.8, 19.8, like that question can be asked. Kindly follow. Next, types of hydrogen bond. There are two types of hydrogen bond. Intermolecular hydrogen bond, intramolecular hydrogen bond. What is the inter? Inter means between two. Intra means within a molecule. Let me explain with a suitable example. Let me take now intermolecular hydrogen bond. Water is a specific example. I am writing, water is a V shape. So I am writing here, kindly follow. So this is the V shape. So kindly follow. So this is, I am calling it as hydrogen bond. What hydrogen bond? Intermolecular hydrogen between two. Kindly follow. So let's just recollect the definition. When hydrogen is placed between two electronegative atoms, then the force of attraction between hydrogen and non-bonded electronegative atom is called hydrogen bond. Non-bonded, not with the bonded, non-bonded. That is the hydrogen bond. Please follow. So water is the liquid, whereas H2S is the gas. The reason is it is due to hydrogen bond. Here hydrogen bond is not present. That is the reason. So we are taking now hydrogen bond as the criteria factor. So this is intramolecular hydrogen bond example, orthonitrophenol. This is an organic compound, a benzene ring. This is phenol. This is NO2, orthonitrophenol. So in order to show the bond, hydrogen bond, I am writing in this technique, in this method, orthonitrophenol. See here, it's a 6-membered ring. 6-membered ring. Now this hydrogen, kindly follow, placed between these two oxygen. But here, this oxygen, this hydrogen, there is no bond is there. So this is now hydrogen bond. But this is within a molecule, this is called intramolecular hydrogen bond. Please follow. So what is the characteristic of this hydrogen bond? A molecule containing intermolecular and intramolecular, what is the difference? Question can be asked. My dear student, please have it in mind. Generally, compounds containing intermolecular hydrogen bond like water will be having high melting and high boiling. Please have it in mind. Future, it will be useful. Whereas, compounds containing intramolecular hydrogen bond will be having low melting and low boiling. Please follow. So when you compare this, that's why it is highly stable. Kindly follow. When you are comparing this, the intermolecular hydrogen bond, if it is present, it is highly stable. Please follow. Now, so now I will come for the questions. In this case, so correct answer is, this is the correct answer. Because only in H2O, hydrogen bond is present. So that is the most stable. See, among the three, H2S is there, H3PO. So these are not correct one. So most stable is water because of intermolecular hydrogen bond. So that is the correct answer. So very, very simple. So even though I have so many explanations, once you know the idea, it's a fraction of second, 1 or 2 seconds to put a tick mark and go. Kindly follow. Let me go for the question number 5. Kindly follow. Question number 5. Asked in 2000, that is NEET 2020. Which of the following set of molecules will have zero dipole moment? Please follow. So zero dipole moment. So what you need for this, what you must know what is a dipole moment. Then what type of molecule will have zero dipole moment, you must know. Let me explain. Kindly follow the theory, do not worry. It is not given in our book. I will explain. So this is the question asked under the classification of element, specifically periodic properties, that is a dipole moment is the extra. So even though it is not included in the periodic properties, it is dipole moment is an important property. It is asked. It is necessary. You have to memorize. Let me explain what is dipole moment. Kindly follow. Dipole moment occurs when there is a separation of charge. When there is a separation of charge. Say for example, HCl. So there is a bond electron. Chlorine high electronegative than hydrogen. Chlorine is 3, hydrogen is 2.2. So the bond electron, kindly follow, move towards chlorine. So this is partial positive, this is partial negative. So automatically this molecule will have dipole moment. So, it occurs between two ions in an ionic bond. This is an ionic bond, or between two atoms in a covalent bond. Please follow. Even in covalent bond, it is present where two atoms are differing in electronegatividity. So, the two atoms connected by a bond, whether it is ionic or covalent, but should differ in electronegativity. That is the important condition. Kindly follow. What is electronegativity? I have already explained under the periodic properties. Kindly follow. Example, HCl, HBr, HI. What is dipole moment? Dipole moment is a measure of the polarity of a molecule. It is given by P equal to Q into D. Q, the product of charges. D, distance between the charges. Please follow. A dipole moment is a vector quantity whose magnitude is Q and the direction is from the negative to positive. So, for example, if we are writing on the water, this is the V shape. So, what will be the vector? Vector will move to the direction is from the negative to positive. Kindly follow. It is now actually positive. Kindly follow. The direction is from negative to positive. The unit of dipole moment, kindly follow. This is actually attracting electron towards this, attracting electron towards this. Kindly follow. So the unit of dipole moment is Coulomb meter centimeter or D by unit. 1 D by unit is equal to 10 to the power of minus 80 electrostatic unit centimeter. So now I will come for the factors. What are the factors which influence dipole moment? Please, my dear students, dipole moment explanation is not given in our CBSE or Samachir book. It is taken from BSc. Please follow. It is very, very important. It depends on electronegativity. It depends upon the distance between, that is the atomic radius, bond distance. Also depends upon the hybridization and shape of the molecule. This is the most important factor. So let me explain. I will give a general idea. My dear students, one important information I want to give here. It is not easy to memorize the dipole moment of all the values. They are not expecting. But what you must know, whether the molecule is having a dipole moment or not. Zero or not zero. That is the only thing they are asking questions. They will not find out the dipole moment, etc. Kindly follow. That may be asked. The question is may be asked, but they are not expecting to memorize all the dipole moments of all the molecule. But if they give molecule, you must say zero or not zero, you must ready. So let me explain how it is. First, let me take type 1. Type 1 means A2. A2 means a diatomic molecule. Whenever you take diatomic, it may be homodiatomic, heterodiatomic. Homodiatomic, you can give example of oxygen. So 0. Anything, chlorine, bromine, iodine, anything you take a diatomic molecule, it is 0. Whereas, if it is heterodiatomic, like HCl, HBr, etc., it is not 0. Dipole moment, it is there. See, example I am giving. HF 1.82, HCl 1.08, HBr 0.82, HI 0.44. So why dipole moment higher for HF? Because of the high the electronegativity. Please follow. The next, let me go for type 2. And the carbon monoxide is given already. The values are given here. Now, let me go for the type 2. Type 2, triatomic. A3 or AB2 or ABC. This is a general. Let me give specifically. A3, AB3 example, O3, ozone. Ozone is not having 0. Because of the shape, the shape will be like this. Kindly follow. So, it is having a value of 0.53 D by unit. It is a non-linear. Please follow. So, when you come for triatomic, what you have to first find out from the shape is a linear or non-linear, you have to identify. That you can easily identify from the hybridization and the lone pair. If you know the hybridization and if you know the lone pair, you can predict the shape. Kindly follow. So in this case, so it is non-linear, kindly follow 0. If it is a linear, kindly follow again 0. Ab2 molecule. Example, Ab2 molecule. If it is a linear, 0. Example, carbon dioxide. Kindly follow what? Carbon dioxide. This is C11O. This is C11O. Vector is actually cancel each other. Kindly follow. The same way carbon disulfide also. So linear triatomic Ab2 type, it is always symmetrical. I will call it as 0. Suppose if it is unsymmetrical, it is having a dipole moment. Example, the chlorocyanogen CnCl. Please follow. Now coming for the non-linear, kindly follow. Linear, symmetrical 0, unsymmetrical non-zero. Whereas non-linear, example water V shape having a value, SO2 again 1.6. Kindly follow. The type 3, I am taking example. So you have to find out A4 or AB3 or A2B2 or A2BC or ABCD, whatever it is. These are the type 4. So you have to find out from the hybridization and lone pair, is the planar or non-planar. If it is a planar molecule, dipole moment is 0. In non-planar dipole moment, it is present. Let me take example, explain. So planar molecule I will take. Let me take boron trifluoride. This is boron. Kindly follow. So what will happen now? The electron is moving towards fluorine, moving towards fluorine, moving towards fluorine. So charge separation taking place. This is negative, negative, this is positive. Kindly follow. So what will happen? Because of the planarity, these two factors are getting cancelled by this vector, this force. So all the three, it is because of the planarity, BF30, same way CLF30, SO30. Kindly follow. PH3, BF3, PCl3, BBr3, all 0. Planar. Please follow. Suppose if it is a non-planar, example ammonia. So from the shape and the lone pair, it is a pyramidal. Ammonia is a pyramidal molecule. What is pyramidal? H, H, H. Kindly follow. So when you compare to hydrogen and nitrogen, it is moving towards like this. Kindly follow. And it is moving. This is the lone pair of electron. So now automatically charge separation taking place. So ammonia is having a dipole moment 1.4D. So NF3 2.24, NCl3 0.63. Kindly follow. Sometimes they will compare which is greater, which is smaller. That can be compared. Comparison. So in this case, NH3, NF3, NCl3, if they are asked which is higher, ammonia is higher, you must know the reason. So because the electronegativity difference between NH3 and NF3, NCl, if you compare between NH3, it is more, charge separation is more, so dipole moment is high. Please follow. So with this idea, now let me go for the questions. Now very, very easy. For just take now, B is the correct answer. Boron trifluoride, just now I have written. Then beryllium dichloride, it is Ab2 molecule, linear, again the both are cancelling, 0, dipole moment. Boron trifluoride, 0. Carbon dioxide, I informed 0. Then 1,2 dichlorobenzene, what is that? This is the structure. This is the structure. That means here the separation. So opposite direction. So 0. So this is the correct answer. My dear student. You go for all other examples, kindly follow nitrogen fluoride. So water it is there. Water is having, the answer is not there. So water here is water. So then again coming for here, hydrogen fluoride is there. So having dipole moment. Very easily you can neglect. This is the key. So this B only, all the 4 will be 0. I hope I have come to the conclusion. My dear students, so you have enjoyed my lecture on classification of element periodic properties. The question discussions, the tricks I have given in the classification of elements and periodic properties. Thank you, my dear student. You are coming for the first time to the YouTube. Click like and click subscribe button and share this information to your friends so that let them also enjoy. So this channel I have started only to help poor people of India. Because the 2 years, the corona period, I was simply sitting inside in my house without going outside. So I want to do something. So that something, why not go to help to the society, poor family society, poor students of India. So that is my idea coming in the form of the channel NEET Chemistry by Dr.R.G channel. Please inform others, others also enjoy. Now here I want to give one important information regarding the students +1, +2 and +2 completed students waiting for NEET common entrance examination for this academic year. Probably it will be May or June it will come. For you, I am giving you one important information. So we are running a coaching center, Vetti coaching center in Pondicherry near bus stand for the last 20 years. And we have our own website, Vetti Daughters, Vetti Namade in Tamil. Now, the Vetti Daughters is having a characteristic feature. It is very far better than any other online coaching in India. How? I will inform you. So, this is containing 200 video lessons, 200 unit test, 200 video lessons taken by professors who are handled with the doctorate degree and 20 to 30 years of experience in the field of teaching IIT and medical students and also BSc, MSc, MPhil, PhD students. So you can feel a classroom atmosphere when you listen the video lesson. And also another important feature, the video lesson full of notes. What way I have shown you now, the same way it will be there. Full of notes. Then what is the advantage? If you touch the video, it will stop, you take the notes and touch again, it will go. Only if it is new information, you can note. Otherwise, not necessary. Okay, right. Coming for the 200 unit test, all the questions are framed only from the previous 20 years of IIT, AIMS, AIFMC, AIPMT, MSET Andhra, Delhi, Karnataka, Kerala, Tamil Nadu, Pondicherry. Only from these question papers I have included. I have not included any question written by teacher. What is the advantage we are experiencing now? For the last 6 years in the NEET common entrance examination conducted by Government of India, we observed 75 to 80 questions, same question repeated. That means you are getting 320 marks, Vetti Daughters giving to you. Then if you are a better student, you will get 300 plus, so you will go to up to 700. You will become a doctor, my dear students. Okay, so here also again, all the unit tests, it's a systematic order and every test you have a video and solution is there. A video solution is there. That is the most important. When you are attending tests, the time is there, clock will go, everything it is there. There is a free version also is there. Go and verify the free version. And if you are interested, join. It is a very low cost. Only 10,000. Others are charging in lakhs. We are charging only 10,000 rupees per year for all the 4 subjects. You can write 200 tests, unit tests. Please follow. All that is. Okay, right. Another interesting information in the test. After the test is over, you can do self-assessment. You can verify in which question you have done mistake, in which question you have done correctly. What way? There is a review called review menu. If you press review after the test, automatically the software will give the mark to you out of 180, 140, something like that. Then if you press review, a window will open. In the window, what will happen? You can see the question number 1. A option, B option, and C, D, and below the correct answer in yellow color, and below the video solution. If you answer A is the correct answer, if you clicked, then your answer will be in blue color, correct answer will be yellow color. So you compare these two and you can identify if they are same, correct. If they are different, your answer is wrong. So self-assessment you can do. So if you go through entire 45 questions, note all the information which are new to you, then again another similar test will be there. Each unit we have 2 tests. So then if now suppose you are getting first time 140 out of 180, now you can improve to 170 to 180. So when you write 200 tests, I can give you assurance you will get minimum out of 720, you will get minimum 700 marks. 650 to 700 marks you will get. So please, if you want to join, so pay 10,000 rupees in the name of Sandhi, Director of Vetri Coaching Center, in Indian Bank account number 7127194771, IFC code ID IB 000P134, cell number 9894176425. So see you again, my dear students, in my next class.